What do companies in e-commerce, entertainment, healthcare, manufacturing, marketing, finance, tech, and hundreds of other industries all have in common? You guessed it, they all use data. Organizations of all kinds need data analysts to help them improve their processes, identify opportunities and trends, launch new products, provide great customer service, and make thoughtful decisions. Hi, I'm Tony, a program manager at Google and a data analyst myself. I'd like to welcome you to the Google Data Analytics Certificate. Now, there are lots of great reasons to earn this certificate. Maybe you're thinking about starting a career in the exciting world of data analytics. Or maybe you're just fascinated by the power of data as I am. No matter what brought you here, you're in the right place to kickstart a career and learn industry-relevant skills in data analytics. But first, what exactly is data? Well, I like to say that data is a collection of facts. This collection can include numbers, pictures, videos, words, measurements, observations, and more. Once you have data, analytics puts it to work through analysis. Data analysis is the collection, transformation, and organization of data in order to draw conclusions, make predictions, and drive informed decision-making. And it doesn't stop there. Data evolves over time, which means this analysis, or analytics as we call it, can give us new information throughout data's entire life cycle. Data is everywhere. You use and create data every day. Have you ever read reviews of a product before deciding whether or not to buy it? That's data analysis. Or maybe you wear a fitness tracker to count your steps so you can stay active throughout the day. That's data analysis. But you don't just use data, you also create huge amounts of it every single day. Anytime you use your phone, look up something online, stream music, shop with a credit card, post on social media, or use GPS to map a route, you're creating data. Our digital world and the millions of smart devices inside of it have made the amount of data available truly mind-blowing. Here at Google, we process more than 40,000 searches every second. That's 3.5 billion searches a day and 1.2 trillion searches every year. Here's another way to think about it. YouTube has almost 2 billion users. If YouTube users made up a country, it would be the largest in the world. All of that data is transforming the world around us. The publication, The Economist, recently called data the world's most valuable resource. So it's easy to see why data analysts are so valued by their organizations. And what exactly does a data analyst do? Put simply, a data analyst is someone who collects, transforms, and organizes data in order to help make informed decisions. Besides the role itself, one of the most exciting parts of being a data analyst is the number of opportunities available. The demand for data analysts is greater than the number of qualified people to fill these job openings. And this certificate program is a great first step in your journey to finding a job you love. Data analysts come from many different backgrounds and have all kinds of life experiences. You don't need decades of work experience or an expensive education to get started. Many data analysts taught themselves the skills they needed to land their first job, just like you're doing right now. Okay, now let's talk more about what you're going to learn. The Google Data Analytics Certificate is split into courses based on different processes for data analysis. Those are Ask, Prepare, Process, Analyze, Share, and Act. Plan to watch these videos in order. Each one covers a new topic, and every topic builds on what you've learned before, making it easy to track your progress. And you're in the driver's seat. Even though you might see things organized by weeks, everything can be completed at your own pace. So you decide how much you want to do each day. By the end of the program, you'll take everything you've learned and turn it into a project that you can use to show off your skills and wow hiring managers at your job interviews. Now, along the way, you'll also hear from Googlers. That's what we call people who work here at Google. They'll give you an inside look at what it's like to work in our industry and share personal stories of how they got into the field. They'll also give you some excellent tips on how to land your dream job. Stay tuned. Some of them are going to introduce themselves in just a sec.
So I'm Angie. I'm a program manager of engineering at Google. I truly believe that cleaning data is the heart and soul of data. It's how you get to know your data, its quirks, its flaws, its mysteries. I love a good mystery, and it felt like a superpower almost. Like I was a detective and I'd gone in there and I'd really solved something.
Hi, I'm Alex. I'm a research scientist at Google. I research the different impacts of artificial intelligence on society and our users.
So my name is Lilah Jones, and I am a part of our cloud team. I get a chance to lead a team of amazing individuals that are focused on helping customers get to the cloud.
Hi, I'm Evan. I'm a learning portfolio manager here at Google. And I have one of the coolest jobs in the world, where I get to look at all the different technologies that affect big data and then work them into training courses like this one for students to take.
I'll be your instructor for the first course. I'll take you through each module that will cover a specific topic in a few different ways. You'll have videos, reading materials, quizzes, hands-on activities, and discussion prompts for you to chat about with other students in an online forum. I'm really excited to be guiding you through this course, but I'm especially excited that you've chosen this adventure. Lifelong learning is something that I'm very passionate about. Growing up, when I looked around, I often didn't see many options available to me. It wasn't until I started getting serious about my education that I realized I had the control to make my own opportunities, with education being the key that would open those doors. The more I learned and the harder I worked, the more possibilities opened up. Had I not gone after that knowledge and continued challenging myself, I may not be where I am today. Learning allowed me to grow personally, be successful, visit places I would never have seen, and meet people I would never have known. And now I'm going to introduce some of those great people.
Hello, I'm Jimena, financial analyst. I'll be helping you learn how to ask the right questions about data, the project you work on, and the problems you're trying to solve.
Hey, my name is Hallie, analytical lead. I am so excited to show you how to prepare your data so it's ready for analysis.
Hello, I'm Sally, measurement and analytical lead. Together, we'll cover how to process and clean your data. Cleaning data doesn't require soap and water. I'm talking about making sure your data is complete, correct, and relevant to the problem you're trying to solve.
Hey, I'm Ayana, Global Insights Manager. We'll be digging into analysis. You'll learn how to collect, transform, and organize data so that you can use it to discover useful information, draw conclusions, and make great decisions.
My name's Kevin, and with my experience as Director of Analytics at Google, I'll guide you through what I think is the most exciting part of the data analysis process. Plan, create, and present effective and compelling data visualizations.
Hello, my name is Carrie. I can't wait to tell you about all the exciting things you can do with the programming language R. Are you ready?
Hi, I'm Rishi, Global Analytics Skills Curriculum Manager. I'm going to help you bring together everything you learned during this program by creating a case study that will dazzle any hiring manager. Just like the capstone of a great building shows everyone that it's complete, your case study will signify your own great achievement of earning a Google certificate in data analytics.
Okay, are you getting excited about the potential of becoming a data analyst? So much is possible with data. You're about to enter a whole new world. Ready? Let's go. Data, data, data. I can't make bricks without clay. Any guesses who said this? I'll give you a hint. It wasn't a famous tech CEO or a data analyst. The person who said this lived long before tech companies even existed. But I bet you've still heard of him. This line was said by Sherlock Holmes, the famous detective created by Sir Arthur Conan Doyle. What Doyle meant was that Holmes couldn't draw any conclusions, which would be the bricks he mentioned, without data, or the clay. You're probably not here to become a world-famous detective, but data is still the building block that you'll use for everything you do in your new data analyst career. Sherlock Holmes would agree. By starting this program, you've shown that you and Sherlock Holmes have something in common. You both have an interest in learning more. That's one of the most important qualities that data analysts can have. Now, there are a bunch of different ways to explore data, but one of the great things about data analytics is that you can often learn how you want, when you want. That might mean doing your own research, talking with people in the industry, or taking online courses. With that said, welcome to your first course. This is your introduction to the wonderful world of data analytics. Since data analytics is the science of data, you'll use this course to begin to learn all about data. Data is basically a collection of facts or information, and through analysis, you'll learn how to use the data to draw conclusions and make predictions and decisions. Personally, I didn't jump right into the data analytics field. I thought data analysis was for computer engineers. Instead, I started off with dreams of working in finance. Once I got through an internship, though, I realized it wasn't the career path I wanted to take. I started to learn about financial planning and analysis and all of the work finance analysts were doing with data. I realized that finance analysts are really just data analysts working in a finance department. These analysts were helping to guide business decisions by knowing how to use data. It was then I realized how powerful data is, and I started to embrace it. Soon enough, I realized I could do this data analysis myself. Data analytics is a big open world of opportunity. There are so many areas your analysis skills can be applied and in all kinds of different ways. If you're new to this world, you'll learn how to identify which path and industry might suit your skills and your interests the best. And for those of you who already have some experience, we'll help you open doors to new and exciting opportunities. One of the skills you'll gain from the program is how to follow the best practices that analysts use to help make data-driven decisions. Computers are one part of the process, but analysts rely on so much more to make decisions. That's why learning how to think analytically and using your other skills and traits on the job will make your work easier. I know you already know how to make good decisions. You chose to be here after all. In this first course, you'll learn more about each phase of the data analysis process. Ask, prepare, process, analyze, share, and act. As a data analyst, you'll go through these steps as you use data to inform your decisions. Eventually, you'll see how this program itself is, in a way, its own version of this process. While I know you'll enjoy watching these videos, your trip through the first course will include a whole lot more. Other videos will take the form of vignettes where you'll learn from data analytics professionals who are already established in their careers. They'll offer words of wisdom as well as tales of their own experiences, starting off on their career path. You'll start your own data journal that will help you keep track of what you've learned throughout the course. You'll also add your own thoughts about what you're learning as well throughout the program. You'll read up on how to navigate this program in the world of data analytics. You'll complete activities, including some that will help you get in the mindset of a data analyst. Along the way, you'll also have the chance to connect with your fellow learners. Discussion prompts will give you a chance to share your thoughts and at the same time, see what your peers think about all that you're learning. These prompts will help you build a community support system to use throughout the program. All right, enough talking. Let's get started on this exciting path. Your next step awaits. Welcome back. At this point, you've been introduced to the world of data analytics and what data analysts do. You've also learned how this course will prepare you for a successful career as an analyst. Coming up, you'll learn all the ways data can be used, and you'll discover why data analysts are in such high demand. I'm not exaggerating when I say every goal and success that my team and I have achieved couldn't have been done without data. Here at Google, all of our products are built on data and data-driven decision-making. From concept to development to launch, we're using data to figure out the best way forward. And we're not alone. Countless other organizations also see the incredible value in data, and of course, the data analysts who help them make use of it. So, we know data opens up a lot of opportunities, but to help you wrap your head around all the ways you can actually use data, let's go over a few examples from everyday life. You might not realize it, but people analyze data all the time. For instance, I'm a morning person. A long time ago, I realized that I'm happier and more productive if I get to bed early and wake up early. I came to this conclusion after noticing a pattern in my day-to-day experiences. When I got 7 hours of sleep and woke up at 6:30, I was the most successful. So I thought about the relationship between this pattern and my daily life. And I predicted that early to bed, early to rise would be the right choice for me. And I'm definitely my best self when I wake up bright and early. I bet you've identified patterns and relationships in your life too. Maybe about your own sleep cycle, or how you feel after eating certain foods, or what time of day you like to work out. All of these are great examples of real-life patterns and relationships that you can use to make predictions about the right actions to take. And that is a huge part of data analysis right there. Now, let's put this process into a business setting. You may remember from an earlier video that there's a ton of data out there. And every minute of every hour of every day, more data is being created. Businesses need a way to control all that data so they can use it to improve processes, identify opportunities and trends, launch new products, serve customers, and make thoughtful decisions. For businesses to be on top of the competition, they need to be on top of their data. That's why these companies hire data analysts to control the waves of data they collect every day, make sense of it, and then draw conclusions or make predictions. This is the process of turning data into insights, and it's how analysts help businesses put all their data to good use. This is actually a good way to think about analysis, turning data into insights. As a reminder, the more detailed definition you learned earlier is that data analysis is the collection, transformation, and organization of data in order to draw conclusions, make predictions, and drive informed decision-making. So after analysts have created insights from data, what happens? Well, a lot. Those insights are shared with others, decisions are made, and businesses take action. And here's where it can get really exciting. Data analytics can help organizations completely rethink something they do or point them in a totally new direction. For example, maybe data leads them to a new product or unique service, or maybe it helps them find a new way to deliver an incredible customer experience. It's these kinds of aha moments that can help businesses reach another level. And that makes data analysts vital to any business. Now that you know more of the amazing ways data is being used every day, you can see why data analysts are in such high demand. We'll continue exploring how analysts can transform data into insights that lead to action. And before you know it, you'll be ready to help any organization find new and exciting ways to transform their data.
Hi, I'm Cassie, and I lead Decision Intelligence for Google Cloud. Decision Intelligence is a combination of applied data science and the social and managerial sciences, and it is all about harnessing the power and beauty of data. I help Google Cloud and its customers turn their data into impact and make their businesses and the world better. A data analyst is an explorer, a detective, and an artist, all rolled into one. Analytics is the quest for inspiration. You don't know what's going to inspire you before you explore, before you take a look around. And so when you begin, you have no idea what you're going to find and whether you're even going to find anything. You have to bravely dive into the unknown and discover what lies in your data. There is a pervasive myth that someone who works in data should know the everything of data. And I think that that's unhelpful because the universe of data has expanded, and it's expanded so much that specialization becomes important. It's very, very difficult for one person to know and be the everything of data. And so that's why we need these different roles. And the advice that I give folks who are entering the space is to pick their specialization based on which flavor, which type of impact best suits their personality. Now, data science, the discipline of making data useful, is an umbrella term that encompasses 3 disciplines: machine learning, statistics, and analytics. These are separated by how many decisions you know you want to make before you begin with them. So if you want to make a few important decisions under uncertainty, that is statistics. If you want to automate, in other words, make many decisions under uncertainty, that is machine learning and AI. But what if you don't know how many decisions you want to make before you begin? What if what you're looking for is inspiration? You want to encounter your unknown unknowns. You want to understand your world. That is analytics. When you're considering data science and you're choosing which area to specialize in, I recommend going with your personality. Which of the 3 excellences in data science feels like a better fit for you? The excellence of statistics is rigor. Statisticians are essentially philosophers, epistemologists. So they are very careful about protecting decision makers from coming to the wrong conclusion. So if that care and rigor is what you are passionate about, I would recommend statistics. Performance is the excellence of the machine learning and AI engineer. You know that's the one for you. If someone says to you, I bet that you couldn't build an automation system that performs this task with 99.99999% accuracy, and your response to that is, watch me. How about analytics? The excellence of an analyst is speed. How quickly can you surf through vast amounts of data to explore it and discover the gems, the beautiful potential insights that are worth knowing about and bringing to your decision makers? Are you excited by the ambiguity of exploration? Are you excited by the idea of working on a lot of different things, looking at a lot of different data sources, and thinking through vast amounts of information while promising not to snooze past the important potential insights? Are you okay being told, here is a whole lot of data, no one has looked at it before, go find something interesting? And do you thrive on creative, open-ended projects? If that's you, then analytics is probably the best fit for you. A piece of advice that I have for analysts getting started on this journey is it can be pretty scary to explore the unknown, but I suggest letting go a little bit of any temptations towards perfectionism and instead enjoying the fun, the thrill of exploration. Don't worry about right answers. See how quickly you can unwrap this gift and find out if there is anything fun in there. It's like your birthday, unwrapping a bunch of things. Some of them you like, some of them you won't. But isn't it fun to know what's actually in there?
Hello again. You've already learned about being a data analyst and how this program will help prepare you for your future career. Now, it's time to explore the data ecosystem, find out where data analytics fits into that system, and go over some common misconceptions you might run into in the field of data analytics. To put it simply, an ecosystem is a group of elements that interact with one another. Ecosystems can be large, like the jungle in a tropical rainforest or the Australian outback, or tiny, like tadpoles in a puddle or bacteria on your skin. And just like the kangaroos and koala bears in the Australian outback, data lives inside its own ecosystem too. Data ecosystems are made up of various elements that interact with one another in order to produce, manage, store, organize, analyze, and share data. These elements include hardware and software tools and the people who use them, people like you. Data can also be found in something called the cloud. The cloud is a place to keep data online rather than on a computer hard drive. So instead of storing data somewhere inside your organization's network, that data is accessed over the internet. So the cloud is just a term we use to describe the virtual location. The cloud plays a big part in the data ecosystem. And as a data analyst, it's your job to harness the power of that data ecosystem. Find the right information and provide the team with analysis that helps them make smart decisions. For example, You could tap into your retail store's database, which is an ecosystem filled with customer names, addresses, previous purchase, and customer reviews. As a data analyst, you could use this information to predict what these customers will buy in the future and make sure the store has the products in stock when they're needed. As another example, let's think about a data ecosystem used by a human resources department. This ecosystem would include information like postings from job websites, stats on the current labor market, employment rates, and social media data on prospective employees. A data analyst could use this information to help their team recruit new workers and improve employee engagement and retention rates. But data ecosystems aren't just for stores and offices, they work on farms too. Agricultural companies regularly use data ecosystems that include information, including geological patterns and weather movements. Data analysts can use this data to help farmers predict crop yields. Some data analysts are even using data ecosystems to save real environmental ecosystems. At the Scripps Institution of Oceanography, coral reefs all over the world are monitored digitally so they can see how organisms change over time, track their growth, and measure any increases or declines in individual colonies. The possibilities are endless. Okay, now let's talk about some common misconceptions you might come across. First is the difference between data scientists and data analysts. It's easy to confuse the two, but what they do is actually very different. Data science is defined as creating new ways of modeling and understanding the unknown by using raw data. Here's a good way to think about it. Data scientists create new questions using data, while analysts find answers to existing questions by creating insights from data sources. There are also many words and phrases you'll hear throughout this course that are easy to get mixed up. For example, data analysis and data analytics sound the same, but they're actually very different things. Let's start with analysis. You've already learned that data analysis is the collection, transformation, and organization of data in order to draw conclusions, make predictions, and drive informed decision-making. Data analytics, in the simplest terms, is the science of data. It's a very broad concept that encompasses everything from the job of managing and using data to the tools and methods that data workers use each and every day. So when you think about data, data analysis, and the data ecosystem, it's important to understand that all of these things fit under the data analytics umbrella. All right, now that you know a little more about the data ecosystem and the differences between data analysis and data analytics, you're ready to explore how data is used to make effective decisions. You'll get to see data-driven decision-making in action. So far, you've discovered that there are many different ways data can be used. In our everyday lives, we use data when we wear a fitness tracker or read product reviews to make a purchase decision. And in business, we use data to learn more about our customers, improve processes, and help employees do their jobs more effectively. But this is just the tip of the iceberg. One of the most powerful ways you can put data to work is with data-driven decision-making. Data-driven decision-making is defined as using facts to guide business strategy. Organizations in many different industries are empowered to make better data-driven decisions by data analysts all the time. The first step in data-driven decision-making is figuring out the business need. Usually, this is a problem that needs to be solved. For example, a problem could be a new company needing to establish better brand recognition so it can compete with bigger, more well-known competitors. Or maybe an organization wants to improve a product and needs to figure out how to source parts from a more sustainable or ethically responsible supplier. Or it could be a business trying to solve the problem of unhappy employees, low levels of engagement, satisfaction, and retention. Whatever the problem is, once it's defined, a data analyst finds data, analyzes it, and uses it to uncover trends, patterns, and relationships. Sometimes the data-driven strategy will build on what's worked in the past. Other times, it can guide a business to branch out in a whole new direction. Let's look at a real-world example. Think about a music or movie streaming service. How do these companies know what people want to watch or listen to? And how do they provide it? Well, using data-driven decision making, they gather information about what their customers are currently listening to, analyze it, then use the insights they've gained to make suggestions for things people will most likely enjoy in the future. This keeps customers happy and coming back for more, which in turn means more revenue for the company. Another example of data-driven decision-making can be seen in the rise of e-commerce. It wasn't long ago that most purchases were made in a physical store, but the data showed people's preferences were changing. So a lot of companies created entirely new business models that removed the physical store and let people shop right from their computers or mobile phones, with products delivered right to their doorstep. In fact, data-driven decision-making can be so powerful, it can make entire business methods obsolete. For example, data help companies completely move away from corded phones and replace them with mobile phones. By ensuring that data is built into every business strategy, data analysts play a critical role in their company's success. But it's important to note that no matter how valuable data-driven decision-making is, data alone will never be as powerful as data combined with human experience, observation, and sometimes even intuition. To get the most out of data-driven decision-making, it's important to include insights from people who are familiar with the business problem. These people are called subject matter experts, and they have the ability to look at the results of data analysis and identify any inconsistencies, make sense of gray areas, and eventually validate choices being made. Organizations that work this way put data at the heart of every business strategy, but also benefit from the insights of their people. It's a win-win. As a data analyst, you play a key role in empowering these organizations to make data-driven decisions, which is why it's so important for you to understand how data plays a part in the decision-making process. We've covered a lot, and I'm sure you have so much to think about already. That's a good thing. It means you've started collecting data and you're doing your own personal analysis. That's what it's all about. You've built a great base already. As this course continues, your knowledge and data analysis skills will continue to grow. Once you've established a solid foundation, you'll apply what you've learned to the rest of the program. The data analysis process will help provide a framework for everything you do. Soon, you'll take your first graded assessment. It's a great way to check your understanding of the concepts and build confidence in your knowledge. Everyone learns at different speeds, so take your time, get familiar with the concepts. As soon as you feel ready, you can go ahead and get started. Keep in mind, if at any point you're not sure about a question, you can always review the videos and readings to remind yourself of the answer. We're all about open book tests here. Once you've passed, you'll be all set to move on. You've got this. Before you know it, you'll be done with all of the courses and you'll be ready to create your own case study. Then, if it's what you want to do, you'll start your job search equipped with the tools and skills that will wow any company you talk to. I can't wait to see where you go with data analytics. For now though, give yourself a pat on the back for a job well done. See you soon. Welcome. Now that you have a solid foundation on the basics of data, it's time to focus on some particular skills and characteristics that will be key to your future career as a data analyst. We'll begin with 5 key skills, move on to the characteristics of analytical thinking, and then learn how data analysts balance their roles and responsibilities. Along the way, you'll also discover how to tap into your own natural abilities for strategy, technical expertise, and data design. These are incredibly helpful skills to have, and you'll learn how to make them even stronger. Finally, you'll be introduced to some fascinating, real-world examples of how data is influencing the lives of people all around the world. All right, let's get started. Earlier, I told you that you already have analytical skills. You just might not know it yet. When learning new things, sometimes people overlook their own skills, but it's important you take the time to acknowledge them, especially since these skills are going to help you as a data analyst. In fact, you're probably more prepared than you think. Don't believe me? Well, let me prove it. Let's start by defining what I'm talking about here. Analytical skills are qualities and characteristics associated with solving problems using facts. There are a lot of aspects to analytical skills, but we'll focus on 5 essential points. They are curiosity, understanding context, having technical mindset, data design, and data strategy. Now, you may be thinking, I don't have these kinds of skills, or I only have a couple of them. But stay with me, and I bet you'll change your mind. Let's start with curiosity. Curiosity is all about wanting to learn something. Curious people usually seek out new challenges and experiences. This leads to knowledge. The very fact that you're here with me right now demonstrates that you have curiosity. All right, that was an easy one. Now, think about understanding context. Context is the condition in which something exists or happens. This can be a structure or an environment. A simple way of understanding context is by counting to 5. 1, 2, 3, 4, 5. All of those numbers exist in the context of 1 through 5. But what if a friend of yours said to you 1, 2, 4, 5, 3? Well, the 3 would be out of context. Simple, right? But it can be a little tricky. There's a good chance that you might not even notice the 3 being out of context if you aren't paying close attention. That's why listening and trying to understand the full picture is critical. In your own life, you put things into context all the time. For example, let's think about your grocery list. If you group together items like flour, sugar, and yeast, that's you adding context to your groceries. This saves you time when you're at the baking aisle at the grocery store. Let's look at another example. Have you ever shuffled a deck of cards and noticed a joker? If you're playing a game that doesn't include jokers, identifying that card means you understand it's out of context. Remove it, and you're much more likely to play a successful game. All right, so now we know you have both curiosity and the ability to understand context. Let's move on to the third skill, a technical mindset. A technical mindset involves the ability to break things down into smaller steps or pieces and work with them in an orderly and logical way. For instance, when paying your bills, you probably already break down the process into smaller steps. Maybe you start by sorting them by the date they're due. Next, you might add them up and compare that amount to the balance in your bank account. This would help you see if you can pay your bills now or if you should wait until the next paycheck. Finally, you'd pay them. When you take something that seems like a single task, like paying your bills, and break it into smaller steps with an orderly process, that's using a technical mindset. Now let's explore the fourth part of an analytical skill set, data design. Data design is how you organize information. As a data analyst, design typically has to do with an actual database. But again, the same skills can easily be applied to everyday life. For example, think about the way you organize the contacts in your phone. That's actually a type of data design. Maybe you list them by first name instead of last, or maybe you use email addresses instead of their names. What you're really doing is designing a clear, logical list that lets you call or text the contact in a quick and simple way. The last, but definitely not least, the fifth and final element of analytical skills is data strategy. Data strategy is the management of the people, processes, and tools used in data analysis. Let's break that down. You manage people by making sure they know how to use the right data to find solutions to the problem you're working on. For processes, it's about making sure the path to that solution is clear and accessible. And for tools, you make sure the right technology is being used for the job. Now, you may be doubting my ability to give you an example from real life that demonstrates data strategy. But check this out. Imagine mowing a lawn. Step 1 would be reading the owner's manual for the mower. That's making sure the people involved, well, you in this example, know how to use the data available. The manual would instruct you to put on protective eyewear and closed-toe shoes. Then it's on to step 2, making the process, the path, clear and accessible. This would involve you walking around the lawn, picking up large sticks or rocks that might get in your way. Finally, for step 3, you check the lawnmower, your tool, to make sure it has enough gas and oil and is in working condition so the lawn can be mown safely. So there you have it. Now you know the 5 essential skills of a data analyst: curiosity, understanding context, having a technical mindset, data design, and data strategy. I told you that you are already an analytical thinker. Now you can start actively practicing these skills as you move through the rest of this course. Curious about what's next? Move on to the next video. Now that you know the 5 essential skills of a data analyst, you're ready to learn more about what it means to think analytically. People don't often think about thinking. Thinking is second nature to us. It just happens automatically. But there are actually many different ways to think. Some people think creatively, some think critically, and some people think in abstract ways. Let's talk about analytical thinking. Analytical thinking involves identifying and defining a problem and then solving it by using data in an organized, step-by-step manner. So as data analysts, how do we think analytically? Well, to answer that question, we will now talk about a second set of 5, the 5 key aspects to analytical thinking. They are visualization, strategy, problem orientation, correlation, and finally, big picture and detail-oriented thinking. Let's start with visualization. In data analytics, visualization is the graphical representation of information. Some examples include graphs, maps, or other design elements. Visualization is important because visuals can help data analysts understand and explain information more effectively. Think about it like this. If you are trying to explain the Grand Canyon to someone, using words would be much more challenging than showing them a picture. A visualization of the Grand Canyon would help you make your point much quicker. Now let's talk about the second part of analytical thinking, being strategic. With so much data available, having a strategic mindset is key to staying focused and on track. Strategizing helps data analysts see what they want to achieve with the data and how they can get there. Strategy also helps improve the quality and usefulness of the data we collect. By strategizing, we know all our data is valuable and can help us accomplish our goals. Next up on the analytical thinking checklist, being problem-oriented. Data analysts use a problem-oriented approach in order to identify, describe, and solve problems. It's all about keeping the problem top of mind throughout the entire project. For example, say a data analyst is told about the problem of a warehouse constantly running out of supplies. They will move forward with different strategies and processes, but the number one goal would always be solving the problem of keeping inventory on the shelves. Data analysts also ask a lot of questions. This helps improve communication and saves time while working on a solution. An example of that would be surveying customers about their experiences, using a product and building insights from those questions to improve that product. This leads us to the 4th quality of analytical thinking, being able to identify a correlation between 2 or more pieces of data. A correlation is like a relationship. You can find all kinds of correlations in data. Maybe it's the relationship between the length of your hair and the amount of shampoo you need. Or maybe you notice a correlation between a rainier season leading to a high number of umbrellas being sold. But as you start identifying correlations in data, there's one thing you always want to keep in mind. Correlation does not equal causation. In other words, just because 2 pieces of data are both trending in the same direction, that doesn't necessarily mean they are all related. We'll learn more about that later. And now, the final piece of the analytical thinking puzzle, big picture thinking. This means being able to see the big picture as well as the details. A jigsaw puzzle is a great way to think about this. Big picture thinking is like looking at a complete puzzle. You can enjoy the whole picture without getting stuck on every tiny piece that went into making it. If you only focus on individual pieces, you wouldn't be able to see past that, which is why big picture thinking is so important. It helps you zoom out and see possibilities and opportunities. This leads to exciting new ideas or innovations. On the flip side, detail-oriented thinking is all about figuring out all of the aspects that will help you execute a plan. In other words, the pieces that make up your puzzle. There are all kinds of problems in the business world that can benefit from employees who have both a big picture and a detail-oriented way of thinking. Most of us are naturally better at one or the other, but you can always develop the skills to fit both pieces together. And now that you know the 5 aspects of analytical thinking, visualization, strategy, problem orientation, correlation, and big picture and detail-oriented thinking, you can put them to work for you when you're working with data. And as you continue through this course, you'll learn how. Let's recap what we've learned about analytical thinking so far. The 5 key aspects are visualization, strategy, problem orientation, correlation, and using big picture and detail-oriented thinking. And we've seen how you already use them in your everyday life. We also talked about how different people naturally use certain types of thinking, but that you can absolutely grow and develop the skills that might not come as easily to you. This means you can become a versatile thinker, which is a very important part of data analysis. You might naturally be an analytical thinker, but you can learn to think creatively and critically, and be great at all 3. The more ways you can think, the easier it is to think outside the box and come up with fresh ideas. But why is it important to think in different ways? Well, because in data analysis, solutions are almost never right in front of you. You need to think critically to find out the right questions to ask, but you also need to think creatively to get new and unexpected answers. Let's talk about some of the questions data analysts ask when they're on the hunt for a solution. Here's one that will come up a lot. What is the root cause of a problem? A root cause is the reason why a problem occurs. If we can identify and get rid of a root cause, we can prevent that problem from happening again. A simple way to wrap your head around root causes is with a process called the 5 whys. In the 5 whys, you ask why 5 times to reveal the root cause. The 5th and final answer should give you some useful and sometimes surprising insights. Here's an example of the 5 whys in action. Let's say you wanted to make a blueberry pie but couldn't find any blueberries. You'd be trying to solve a problem by asking, why can't I make a blueberry pie? The answer would be, there were no blueberries at the store. There's why number 1. So you then ask, why were there no blueberries at the store? And discover that the blueberry bushes don't have enough fruit this season. That's why number 2. Next you'd ask, why was there not enough fruit? This would lead to the fact that birds were eating all the berries. Why number 3, asked and answered. Now we get to why number 4. Ask why a 4th time, and the answer would be that although the birds normally prefer mulberries and don't eat blueberries, the mulberry bushes didn't produce fruit this season. So the birds are eating blueberries instead. And finally, we get to why number 5, which should reveal the root cause. A late frost damaged the mulberry bushes, so they didn't produce any fruit. So you can't make a blueberry pie because of a late frost months ago. See how the 5 whys can reveal some very surprising root causes? This is a great trick to know, and it can be a very helpful process in data analysis. Another question commonly asked by data analysts is, where are the gaps in our process? For this, many people will use something called gap analysis. Gap analysis lets you examine and evaluate how a process works currently in order to get where you want to be in the future. Businesses conduct gap analysis to do all kinds of things, such as improve a product or become more efficient. The general approach to gap analysis is understanding where you are now compared to where you want to be. Then, you can identify the gaps that exist between a current and future state and determine how to bridge them. A third question that data analysts ask a lot is, what did we not consider before? This is a great way to think about what information or procedure might be missing from a process, so you can identify ways to make better decisions and strategies moving forward. These are just a few examples of the kinds of questions data analysts use at their jobs every day. As you begin your career, I'm sure you'll think of a whole lot more. The way data analysts think and ask questions plays a big part in how businesses make decisions. That's why analytical thinking and understanding how to ask the right questions can have such a huge impact on the overall success of a business. Later, we'll talk more about how data-driven decisions can lead to successful outcomes. In an earlier video, you learned about 5 essential analytical skills. As a reminder, they are curiosity, understanding context, having a technical mindset, data design, and data strategy. In the next couple of videos, we'll explore how these abilities all become part of data-driven decision-making. But first, let's look at the concept of data-driven decision-making and why it's more likely to lead to successful outcomes. You might remember that data-driven decision-making involves using facts to guide business strategy. Data analysts can tap into the power of data to do all kinds of amazing things. With data, they can gain valuable insights, verify their theories or assumptions, better understand opportunities and challenges, support an objective, help make a plan, and much more. In business, data-driven decision-making can improve the results in a lot of different ways. For example, say a dairy farmer wants to start making and selling ice cream. They could guess what flavors customers would like, but there's a better way to get the information. The farmer could survey people and ask them what flavors they prefer. This gives the farmer the data they need to pick ice cream flavors people will enjoy. Here's another example. Let's say the president of an organization is curious about what perks employees value most. She asked the human resources director, who says people value casual dress code. It's a gut feeling, but the HR director backs it up with the fact that he sees a lot of people wearing jeans and t-shirts. But what if this company were to use a more structured employee feedback process, such as a survey? It might reveal that employees actually enjoy free public transportation cards the most. The human resources director just didn't realize that because he drives to work. These are just some of the benefits of data-driven decision-making. It gives you greater confidence about your choice and your abilities to address business challenges. It helps you become more proactive when an opportunity presents itself, and it saves you time and effort when working towards a goal. Now let's learn more about how these 5 skills help you tap into all the potential of data-driven decision-making. First, think about curiosity and context. The more you learn about the power of data, the more curious you're likely to become. You'll start to see patterns and relationships in everyday life, whether you're reading the news, watching a movie, or going to an appointment across town. The analysts take their thinking a step further by using context to make predictions, research answers, and eventually draw conclusions about what they've discovered. This natural process is a great first step in becoming more data-driven. Having a technical mindset comes next. Everyone has instincts, or, as in the case of our human resources director example, gut feelings. Data analysts are no different. They have gut feelings too, but they've trained themselves to build on those feelings and use a more technical approach to explore them. They do this by always seeking out the facts, putting them to work through analysis, and using the insights they gain to make informed decisions. Next, we come to data design, which has a strong connection to data-driven decision-making. To put it simply, designing your data so that it's organized in a logical way makes it easy for data analysts to access, understand, and make the most of available information. And it's important to keep in mind that data design doesn't just apply to databases. This kind of thinking can work with all sorts of real-life situations too. The basic idea is this. If you make decisions that are informed by data, you are more likely to make more informed and effective decisions. The final ability is data strategy, which incorporates the people, processes, and tools used to solve a problem. This is a big one to remember because data strategy gives you a high-level view of the path you'll need to take to achieve your goals. Also, data-driven decision-making isn't a one-person job. It's much more likely to be successful if everyone is on board and on the same page. So it's important to make sure specific procedures are in place and that your technology being used is aligned with your data-driven strategy. Now you know how these 5 essential analytical skills work towards making better data-driven decisions. So far, many of the examples you've heard are hypothetical. That means they could be true in theory, but aren't specific real-world cases. Next, we'll look at some real examples. I can't wait to share how data analysts put data to work for amazing results. In this video, I'm going to share some case studies that highlight the incredible work data analysts do. Each of these scenarios shows off the power of data-driven decision-making in unexpected ways. The first story is about Google. As I mentioned a little while back, here at Google, our mission is to organize the world's information and make it universally accessible and useful. All of our products, from idea to development to launch, are built on data and data-driven decision-making. There are tons of examples here at Google of people using facts to create business strategy. But one of the most famous ones has to do with Google's human resources. So here's how it went. The HR department wanted to know if there was value in having managers. Were their contributions worthwhile, or should everyone just be an individual contributor? To answer that question, Google's People Analytics team looked at past performance reviews and employee surveys. The data they found was plotted on a graph because, as you've learned, visuals are extremely helpful when trying to understand a problem or concept. The graph revealed that Googlers had positive feelings about their managers, but the data was pretty general, and the team wanted to learn more. So they dug deeper and split the data into quartiles. A quartile divides data points into 4 equal parts, or quarters. Here's where the really cool stuff started happening. The data analysts discovered that there was a big difference between the very top and the very bottom quartiles. As it turned out, the teams with the best managers were significantly happier, more productive, and more likely to want to keep working at Google. This confirmed that managers were valued and make a big difference. Therefore, the idea of having only individual contributors was not implemented. But there was still more work to do. Just knowing that great managers create great results doesn't lead to actionable insights. You have to identify what exactly makes a great manager. So the team took 2 additional steps to collect more data. First, they launched an awards program where employees could nominate their favorite managers. For every submission, you had to provide examples or data about what makes that manager great. The second step involved interviewing managers who are graphed on the top and bottom quartiles. This helped the analytics team see the differences between successful and less successful management behaviors. The best behaviors were identified, as were the most common reasons for a manager needing improvement. The final step was sharing these insights and putting a procedure in place for evaluating managers with these qualities in mind. This data-driven decision continues to create an exceptional company culture for my colleagues and me. Thanks, data. Another interesting example comes from the nonprofit sector. Nonprofits are organizations dedicated to advancing a social cause or advocating for a particular effort, such as food security, education, or the arts. In this case, data analysts research how journalists can make a more meaningful impact for the nonprofits they would write about. Because journalists write for newspapers, magazines, and other news outlets, they can help nonprofits reach readers like you and me, who then take action to help nonprofits reach their goals. For instance, say you read about the problem of climate change in an online magazine. If the article is effective, you learn more about the cause and might even be compelled to make greener choices in your day-to-day life, volunteer for a nonprofit, or make a donation. That's an example of the journalist's work bringing about awareness, understanding, and engagement. So, back to the story. The data analysts used a tracker to monitor story topics, clicks, web traffic, comments, shares, and more. Then, they evaluated the information to make recommendations for how the journalists could do their jobs even better. In the end, they came up with some great ideas for how nonprofits and journalists can motivate people everywhere to work together and make the world a better place. There's really no end to what you can do as a data analyst. As you progress through this program, you'll discover even more possibilities. Great job following along with the topics in these past few videos. You learned all about analytical skills and the 5 key characteristics of data analysts. You probably even learned that you're a pro at most of these already. Next, you discovered what it means to think analytically and the specific skills data analysts develop to help them do it. You explore tools and processes that enable data analysts to pinpoint a problem and ask the right questions in order to solve it. Finally, some real-world stories helped illustrate why data-driven decision-making is usually more successful than other methods. You're building a wonderful foundation for your career as a data analyst. With every video, your skills will continue to expand and your understanding of key data analytics concepts will only get stronger. Soon, you'll have a chance to test out everything you've learned. This is a really useful opportunity to check your understanding of all the concepts we've discussed. And if you're ever unsure about a question, you can review the videos and readings to find the answer. This is another awesome way to practice collecting data. Keep up the great work. Hey, it's great to have you back. So we've talked a little bit about the data analysis process. As a quick refresher, the data analysis process phases are ask, prepare, process, analyze, share, and act. You might remember me saying earlier that this entire program is modeled after these steps. So now, we're going to really dig in and explore how each of these phases work together. But I'm getting a little ahead of myself. First, let's spend a little time understanding the data life cycle. No, data isn't actually alive, but it does have a life cycle. So how do data analysts bring data to life? Well, it starts with the right data analysis tool. These include spreadsheets, databases, query languages, and visualization software. Don't worry if you don't know how these work, or even what they are. At one point, every data analyst has been right where you are right now, and they probably had a lot of the same questions. I remember when I first started learning about spreadsheets. I was a young intern, and the company I was working for was in the middle of a big systems change. That meant we had to move tons of reports from the old system to the new one. After a few weeks, I noticed that even the people who are further in their careers were not as technically minded as I was. So that became a great opportunity for me to add value. My aha spreadsheet moment came when I started researching shortcuts that I could use to work with the spreadsheets more efficiently. This would really streamline the process of getting those reports moved over to the new system. Once everything started flowing, I remember getting emails from other finance analysts at the company. They were so grateful that someone had come in and fixed a problem that no one else could. That inspired me to go even further and learn how to use spreadsheets in all sorts of incredible ways. As you continue through this course, I bet you'll be just as impressed as I was. And before you know it, you'll bring data to life too. Let's get started. Here's a question for you. When you think about a life cycle, what's the first thing that comes to mind? Now, I'm not a mind reader, but I know whatever you're thinking is right. There's actually no wrong answer because everything has a life cycle. One of the most well-known examples of a life cycle is a butterfly. Butterflies begin as eggs, hatch into caterpillars, and then become a chrysalis. That's where the real magic happens. Data has a life cycle of its own too. In this video, we're going to talk about each of the stages in that life cycle to help you understand the individual phases data goes through. The life cycle of data is plan, capture, manage, analyze, archive, and destroy. Let's start with the first phase, planning. This actually happens well before starting an analysis project. During planning, a business decides what kind of data it needs, how it will be managed throughout its life cycle, who will be responsible for it, and the optimal outcomes. For example, let's say an electricity provider wanted to gain insights into how to save people energy. In the planning phase, they might decide to capture information on how much electricity its customers use each year, what types of buildings are being powered, and what types of devices are being powered inside of them. The electricity company would also decide which team members would be responsible for collecting, storing, and sharing that data. All of this happens during planning, and it helps set up the rest of the project. The next phase is when you capture data. This is where data is collected from a variety of different sources and brought into the organization. With so much data being created every day, the ways to collect it are truly endless. One common method is getting data from outside resources. For example, if you're doing data analysis on weather patterns, you'd probably get data from a publicly available data set like the National Climatic Data Center. Another way to get data is from a company's own documents and files, which are usually stored inside a database. While we've mentioned databases before, we haven't gone into too much detail about what they are. A database is a collection of data stored in a computer system. In the case of our electricity provider, the business would probably measure data usage among its customers within a database that it owns. As a quick note, when you maintain a database of customer information, ensuring data integrity, credibility, and privacy are all important concerns. You'll learn a lot more about that later on. Now that we've captured our data, we move on to the next phase of the data lifecycle, manage. Here we're talking about how we care for our data, how and where it's stored, the tools used to keep it safe and secure, and the actions taken to make sure that it's maintained properly. This phase is very important to data cleansing, which we'll cover later on. Next, it's time to analyze your data. This is where data analysts really shine. In this phase, the data is used to solve problems, make great decisions, and support business goals. For example, one of our electricity company's goals might be to find ways to help customers save energy. Moving on, the data lifecycle now evolves to the archive phase. Archiving means storing data in a place where it's still available but may not be used again. During analysis, analysts handle huge amounts of data. Can you imagine if we had to sort through all of the available data that's out there, even if it was no longer useful and relevant to our work? It makes way more sense to archive it than to keep it around. And finally, the last step of the data lifecycle, the destroy phase. Yes, it sounds sad, but when you destroy data, it won't hurt a bit. So let's get back to our electricity provider example. They would have data stored on multiple hard drives. To destroy it, the company would use a secure data erasure software. If there were any paper files, they would be shredded too. This is important for protecting a company's private information, as well as private data about its customers. And there you have it, the data life cycle. And now that you understand the different phases data goes through during its life cycle, you can better understand how to approach the data analysis process, which we'll talk about soon. Now that you understand all the phases of the data life cycle, it's time to move on to the phases of data analysis. They sound similar, but are two different things. Data analysis isn't a life cycle. It's the process of analyzing data. Coming up, we'll look at each step of the data analysis process and how it will relate to your work as a data analyst. Even this program is designed to follow these steps. Understanding these connections will help guide your own analysis and your work in this program. You've already learned that this program is modeled after the stages of the data analysis process. This program is split into courses, 6 of which are based upon the steps of data analysis: ask, prepare, process, analyze, share, and act. Okay, let's start with the first step in data analysis, the ask phase. In this phase, we do 2 things. We define the problem to be solved, and we make sure that we fully understand stakeholder expectations. Stakeholders hold a stake in the project. They are people who have invested time and resources into a project and are interested in the outcome. Let's break that down. First, defining a problem means you look at the current state and identify how it's different from the ideal state. Usually, there's an obstacle we need to get rid of or something wrong that needs to be fixed. For instance, a sports arena might want to reduce the time fans spend waiting in the ticket line. The obstacle is figuring out how to get the customers to their seats more quickly. Another important part of the ask phase is understanding stakeholder expectations. The first step here is to determine who the stakeholders are. That may include your manager, an executive sponsor, or your sales partners. There can be lots of stakeholders, But what they all have in common is that they help make decisions, influence actions and strategies, and have specific goals they want to meet. They also care about the project, and that's why it's so important to understand their expectations. For instance, if your manager assigns you a data analysis project related to business risk, it would be smart to confirm whether they want to include all types of risks that could affect the company, or just risks related to weather, such as hurricanes and tornadoes. Communicating with your stakeholders is key in making sure you stay engaged and on track throughout the project. So as a data analyst, developing strong communication strategies is very important. This part of the ask phase helps you keep focused on the problem itself, not just its symptoms. As you learned earlier, the 5 whys are extremely helpful here. In an upcoming course, you'll learn how to ask effective questions and define the problem by working with stakeholders. You'll also cover strategies that can help you share what you discover in a way that keeps people interested. After that, we'll move on to the prepare step of the data analysis process. This is where data analysts collect and store data they'll use for the upcoming analysis process. You'll learn more about the different types of data and how to identify which kinds of data are most useful for solving a particular problem. You'll also discover why it's so important that your data and results are objective and unbiased. In other words, any decisions made from your analysis should always be based on facts and be fair and impartial. Next is the process step. Here, data analysts find and eliminate any errors and inaccuracies that can get in the way of results. This usually means cleaning data, transforming it into more useful format, combining 2 or more data sets to make information more complete, and removing outliers, which are any data points that could skew the information. After that, you'll learn how to check the data you prepared to make sure it's complete and correct. This phase is all about getting the details right, so you'll also fix typos, inconsistencies, or missing and inaccurate data. And to top it off, you'll gain strategies for verifying and sharing your data cleansing with stakeholders. Then it's time to analyze. Analyzing the data you've collected involves using tools to transform and organize that information so that you can draw useful conclusions, make predictions, and drive informed decision making. There are lots of powerful tools data analysts use in their work, and in this course you'll learn about 2 of them: spreadsheets and structured query language, or SQL, which is often pronounced SQL. The next course is based on the share phase. Here, you'll learn how data analysts interpret results and share them with others to help stakeholders make effective, data-driven decisions. In the share phase, visualization is a data analyst's best friend. So this course will highlight why visualization is essential to getting others to understand what your data is telling you. With the right visuals, facts, and figures become so much easier to see, and complex concepts become easier to understand. We'll explore different kinds of visuals and some great data visualization tools. You'll also practice your own presentation skills by creating compelling slideshows and learning how to be fully prepared to answer questions. Then we'll take a break from the data analysis process to show you all of the really cool things you can do with the programming language R. You don't need to be familiar with R or programming languages in general. Just know that R is a popular tool for data manipulation, calculation, and visualization. And for our final data analysis phase, we have ACT. This is the exciting moment when the business takes all of the insights you, the data analyst, have provided and puts them to work in order to solve the original business problem. And will be acting on what you've learned throughout this program. This is when you'll prepare for your job search and have the chance to complete a case study project. It's a great opportunity for you to bring together everything you've worked on throughout this course. Plus, adding a case study to your portfolio helps you stand out from the other candidates when you interview for your first data analyst job. Now you know the different steps of the data analysis process and how our course reflects it. You have everything you need to understand how this course works. And my fellow Googlers and I will be here to guide you every step of the way.
Regardless of what type of data analysis you're conducting, the process is generally the same. The example that I'll walk through is that of our employee engagement survey, but you can imagine that this process applies to just about any data analysis that you're going to conduct as an analyst. The first thing you want to do is ask, You want to ask all of the right questions at the beginning of the engagement so that you better understand what your leaders and stakeholders need from this analysis. So the types of questions that I generally ask are around, what is the problem that we're trying to solve? What is the purpose of this analysis? What are we hoping to learn from it? So after you've asked all the right questions and you've wrapped your arms around the scope of the analysis you need to conduct, the next step is to prepare. We need to be thinking about what type of data we need to answer those key questions. This could be anything from quantitative data or qualitative data. It could be cross-sectional or point in time versus longitudinal over a long period of time. We need to be thinking about the type of data we need in order to answer the questions that we've set out to answer based on what we learned when we asked the right questions. We also need to be thinking about how we're going to collect that data, or if we need to collect that data. It may be the case that we need to collect this data brand new, and so we need to think about what type of data we're going to be collecting and how. For our employee engagement survey, we do that via a survey of both quantitative and qualitative questions. But it may actually be the case that for many analyses, the data that you're looking for already exist. Then it's a question of working with those data owners to make sure that you're able to leverage that data and use it responsibly. After you've done all the hard work to collect your data, now you need to process that data. It begins with cleaning. This, to me, is the most fun part of the data analytics process. We can think of it as the initial introduction or the handshake, hello to your data. This is where you get a chance to understand its structure, its quirks, its nuances, and you really get a chance to understand deeply what type of data you're going to be working with and understanding what potential that data has to answer all of your questions. This is such an important part, too, where we're running through all of our quality assurance checks. For example, do we have all of the data that we anticipated we would have? Are we missing data at random, or is it missing in a systematic way such that maybe something went wrong with our data collection effort? If needed, did we code all of our data the right way? Are there any outliers that we need to treat differently? This is the part where you spend a lot of time really digging deeply into the structure and nuance of the data to make sure that you're able to analyze it appropriately and responsibly. After cleaning our data and running all of our quality assurance checks, now is the point where we analyze our data, making sure to do so in as objective and unbiased a way as possible. To do this, the first thing we do is run through a series of analyses that we've already planned ahead of time based on the questions that we know we want to answer from the very, very beginning of the process. One thing that's probably the hardest about this particular process, the hardest thing about analyzing data, is that we as analysts are trained to look for patterns. And over time, as we become better and better at our jobs, what we'll often find is that we can start to intuit what we might see in the data. We might have a sneaking suspicion as to what the data are going to tell us. And this is the point where we have to take a step back and let the data speak for itself. As data analysts, we are storytellers, but we also have to keep in mind that it is not our story to tell. That story belongs to the data, and it is our job as analysts to amplify and tell that story in as unbiased and objective a way as possible. The next step is to share all of the data and insights that you've generated from your analyses. Now, typically for our employee engagement survey, we start by sharing the high-level findings with our executive team. We want them to have a landscape view of how the organization is feeling, and we want to make sure that there aren't any surprises as they dig deeper and deeper into the data to understand how teams are feeling and how individual employees are feeling. All of this work, from asking the right questions to collecting your data to analyzing and sharing, doesn't mean much of anything if we aren't taking action on what we've just learned. This, to me, is the most critical part, especially of our employee engagement survey. I like to say that the survey is actually the easy part, and acting on the results is really where the real work begins. This is where we use all of those data-driven insights to decide what types of interventions we want to introduce, not only at the organizational level, but also at the team level as well. So we might find, for example, that the organization is working on a series of interventions to help improve part of the employee experience, whereas individual teams have additional roles and responsibilities to play to either bolster some of those efforts or to introduce new ones to sort of better meet their team where their strengths and opportunity areas are. The data analysis process is rigorous, but it is lengthy, and I can completely appreciate that we as data analysts get so excited about just diving right into the data and doing what we do best. The challenge is that if we don't work through the process in its entirety, if we try to skip steps, we're not going to be able to elicit the insights that we're looking for. I absolutely love my job. I have such a deep appreciation for data and what it can do and what type of insight we can derive from it.
I'm looking forward to introducing you to some of the tools data analysts use each and every day. There are tons of options out there, but the most common ones you'll see analysts use are spreadsheets, query languages, and visualization tools. And this video is going to give you a quick look at how these tools are being used by data analysts every day. Believe it or not, I was several years into my accounting and finance career before I saw all of these tools working together. At that point, I was very experienced with spreadsheets and had worked in large data sets with some of the traditional database programs. I had the foundational skill set to use query languages, and I had dabbled in visualizations, but I had never brought them all together. Then I got hired here at Google, and it was so eye-opening to come into a place like this with an abundance of information everywhere you look. As an analyst at Google, the true power of these tools became so much clearer to me. I became more focused on really maximizing everything these tools could do, streamlining my reporting, and just making my work simpler. All of a sudden, I had a lot more time and space to dedicate to identifying new problems to solve and driving decision-making. Without a doubt, once you've learned the power of these tools, you will be well on your way to becoming the best data analyst you can possibly be. All right, I hope that story has you even more motivated for this course. Let's get started with spreadsheets. Again, there are lots of different spreadsheet solutions, but two popular options are Microsoft Excel and Google Sheets. To put it simply, a spreadsheet is a digital worksheet. It stores, organizes, and sorts data. This is important because the usefulness of your data depends on how well it's structured. When you put your data into a spreadsheet, you can see patterns, group informations, and easily find the information you need. Spreadsheets also have some really useful features called formulas and functions. A formula is a set of instructions that performs a specific calculation using the data in a spreadsheet. Formulas can do basic things like add, subtract, multiply, and divide. But they don't stop there. You can also use formulas to find the average of a number set, look up a particular value, return the sum of a set of values that meets a particular rule, and so much more. A function is a preset command that automatically performs a specific process or task using the data in the spreadsheet. That sounds pretty technical, I know. So let's break it down. Just think of a function as a simpler, more efficient way of doing something that would normally take a lot of time. In other words, functions can help make you more efficient. Those are the spreadsheet basics for now. Later on, you'll see them in action and start working with spreadsheets yourself. The next data analysis tool is called query language. A query language is a computer programming language that allows you to retrieve and manipulate data from a database. You'll learn something called structured query language, more commonly known as SQL. SQL is a language that lets data analysts communicate with a database. A database is a collection of data stored in a computer system. SQL is the most widely used structured query language for a couple of reasons. It's easy to understand and works very well with all kinds of databases. With SQL, data analysts can access the data they need by making a query. Although query means question, I like to think of it as more of a request. So, you're requesting that the database do something for you. You can ask it to do a lot of different things, such as insert, delete, select, or update data. Okay, that's a top-level look at SQL. In a later video, we'll explore it further and use SQL to do some really cool things with data. Lastly, let's talk about data visualization. You've learned that data visualization is the graphical representation of information. Some examples include graphs, maps, and tables. Most people process visuals more easily than words alone. That's why visualizations are so important. They help data analysts communicate their insights to others in an effective and compelling way. When you think about the data analysis process, after data is prepared, processed, and analyzed, the insights are visualized so it can be understood and shared. This makes it easier for stakeholders to draw conclusions, make decisions, and come up with strategies. Some popular visualization tools are Tableau and Looker. Data analysts like using Tableau because it helps them create visuals that are very easy to understand. This means that even non-technical users can get the information they need. Looker is also popular with data analysts because it gives them an easy way to create visuals based on the results of a query. With Looker, you can give stakeholders a complete picture of your work by showing them visualization data and the actual data related to it. All visualization tools have great features that are useful in different situations. Soon, you'll learn how to decide which tool to use for a particular job. And that's everything you need to know about the data lifecycle and the data analysis process. You'll get a chance to test out what you know so you can feel confident moving forward in this course. Feel free to take some time to refamiliarize yourself with the concepts. And when you're ready, give it your best shot. If you're ever unsure of an answer, you can always go back and review the videos and readings. Then you'll be ready to move on to the next set of videos where we'll continue exploring the data analytics tools you've already covered, and you'll get some really fascinating insights into exactly how they work. Before long, you'll have the knowledge and confidence to start using them yourself. Stay tuned. Welcome back. In the next few videos, you'll continue to explore the data analytics tools we discussed earlier, and you'll get the chance to see them in action a little bit. This will give you a clearer picture of how to use these tools. The rest of the program will build on from what you learned here. We'll start with a closer look at spreadsheets. We'll break spreadsheets down to their basics to better understand a few of their features and functions. You'll also learn how you might want to use them in your work as a data analyst. For example, how do you sort your data to make it easier to use? We'll find out. Next, we'll see SQL in action. Data analysts use SQL in their work all the time, like when they need a large amount of data in seconds to help answer a quick business question. Chances are you're not familiar with SQL. That's okay. You'll learn how using SQL is just like ordering food at a super speedy restaurant. Your SQL query might not be as delicious, but you won't have to wait long to get your order. Speaking of food, what better topic than dessert? You can think of data visualization as the dessert to the meal of data analytics. It's served at the end of your analysis after you've done what you need to get the right data for a question or task. We've already seen that visualizations come in a lot of forms, like graphs or charts. And just like dessert, they're a treat to look at. You'll learn more about these visual representations and see other examples of how they might look. Then, you'll get to talk about visualizations with other future data analysts just like yourself. We'll wrap things up with an assessment, but you'll have time to review what you've learned before then. Okay, let's keep going. By the way, is anyone else hungry now? On October 17th, 2019, we celebrated the 40th anniversary of a very special event. Well, special for people like me anyway. In 1979, VisiCalc was introduced to the world as the first computer spreadsheet program. While spreadsheets have changed a lot since then, it was still an important achievement. And so now we celebrate October 17th every year as Spreadsheet Day. While there's a good chance you've never been to a Spreadsheet Day party, spreadsheets are a big part of data analytics. The sooner you make friends with spreadsheets, the better. Trust me, they'll save you a lot of time as a data analyst and make your job easier. This spreadsheet is one example of how an organized spreadsheet might look. In this video, we'll demonstrate some basic spreadsheet concepts for all of you who are new to this world. This might be a review for some of you more experienced folks out there, but it never hurts to practice what you know. Plus, you might still learn a new trick or two. I showed you this image earlier. Let's explore it further because it's a great example of the three main features of a spreadsheet: cells, rows, and columns. They'll be a part of almost everything you do in a spreadsheet, from making a simple grocery list to analyzing a complex data set. I use spreadsheets to manage everything from my own personal finances to the annual homecoming party my friends and I have every year. I'm the planner, so I use a spreadsheet to keep things in order, making sure we have everything we need. Speaking of keeping things in order, the columns in a spreadsheet are ordered by letter, and the rows are ordered by number. So when you talk about a specific cell, you name it by combining the column, letter, and row number where the cell is located. For example, in this spreadsheet, the word row is in cell D3. Pretty simple, right? Let's get started in an actual spreadsheet. You can complete all of these steps in just about any spreadsheet program. Let's get to know your spreadsheet a little better now. All right, we'll start with some basic operations. Keep in mind, as an analyst, you won't always create your own data sets, but for now, let's do just that. I'll click in cell A2 and type my first name in the cell like this. Next, I'll click in cell B2 and type my last name. Don't worry if your name doesn't fit in the cell. You can always make the columns wider if you need to. All you have to do is click and drag the right edge of the column until the name fits. Or you can also use the text wrapping feature, which will set cells to automatically change their height and allow the text in the cell to fit. To use this feature, select the cells, columns, or rows with text. Then use the Format menu to look at the text wrapping options. It is automatically set to allow the text to overflow out of the cell. But you can wrap the text instead, so all of the text is visible. The clip option will cut off the text in the cell, so only the text that fits is visible. There it is. We've added data. Now let's label the data. This is important for organization. Adding labels to the top of the columns will make it easier to reference and find data later on when you're doing analysis. The column labels are usually called attributes. An attribute is a characteristic or quality of data used to label a column in a table. You might hear them called variables, or a few other names too. All right, let's add some attributes to our data. I'll click in cell A1 and type the words first name. In cell B1, I'll type last name. We'll make these attributes bold so they stand out more. Spreadsheets can be really big, so you want to make sure your data is clearly labeled and easy to find. So let's make these attributes stand out. I can use my cursor to select the cells with the attributes. Then I'll click the bold icon to make the attributes bold. Looking good so far. Ready to add some more data? Let's start with some new attributes. First, I'll add a column for age by typing age in cell C1. Then I'll add two more attributes in the next two columns. Let's go with favorite color and favorite dessert. I'll make them bold too. And to fit the labels in the cells, I'll adjust the size of the columns just like before. Now keep in mind, there are more ways to adjust the size of columns and rows. If you have questions about using spreadsheets, a quick search online will usually help you find what you need. We've also included a reading with more tips and information about spreadsheets. Okay, let's get back to it. Now, I can add my own data to the data set. I'll type in my age and favorite color and dessert in the appropriate cells. Next, I'll add data for two more people. We now have 3 rows of data. In a data set, a row is called an observation. An observation includes all of the attributes for something contained in a row of a data table. In this case, row 3 is an observation of Willa Stein because we see all of her attributes in this row. So now we know spreadsheets let you do lots of things with data. You can store and organize data like we've done in this spreadsheet, but you can go even further and reorganize existing data too. Here, I'll show you how. Let's say we want to organize our data by age. There's a simple way to do that. First, we'll need to select all of our columns with data so that all of it gets reorganized together. Then we can go to our data menu. Here, we have some options. Let's select Sort Range. This will let us choose how to organize the column. Next, we'll choose A to Z, which will organize our numbers in order from the smallest to the largest. Now, we want to watch out for our header row, which is the word age, the attribute for this column. We'll check that box. This makes sure that the word age stays in place. All right, now we're ready to sort. Voila! We just reorganized our data by sorting it from the smallest number to largest. And as we go further, you'll discover lots of other ways to work with data in a spreadsheet, including functions and formulas. Let's finish with a quick example of a formula. You can think of formulas as one way of manipulating data in a spreadsheet. Formulas are like a calculator, but more powerful. A formula is a set of instructions that performs a specific calculation using the data in a spreadsheet. To do this, the formula uses cell references for the values it's calculating. Let me show you. Here we go. We'll click in the next cell in the age column. Then we'll type an equal sign. All formulas begin with this symbol. Next, we type average. This is the function we are using in the formula. We've briefly discussed how functions work before, but it's okay if you don't completely understand them yet. We'll take a closer look later on. In this case, we follow the function average with the left parentheses. Now, we can add the names of the cells where we find the data we're using. These are the cell references the formula will use to make its calculation. We'll start at the top with cell C2. C2 represents the value in the cell, in this case, 36. Then we'll add a colon next to it, which shows that we have a range of numbers in consecutive cells. Finally, we complete our formula by adding the last cell reference in the range, C4, and a right parentheses to end it. Then we press enter to perform the calculation. And there it is. The formula has given us the average age of the ages in this data set. We've just analyzed some data. We'll want to store the data for later use. In Google Sheets, a spreadsheet is automatically saved in your Google Drive. For Excel and other spreadsheets, you'll save them as a file. And now you know some basics for using spreadsheets. Once you're used to these concepts, you'll be able to learn even more about spreadsheet tools. It's a lot to digest, so feel free to rewatch and practice on your own. You can even make your own version of this spreadsheet with your own data. We'll work together in the spreadsheet soon as well. For now, good job for sticking with me through this. It'll be worth it. As you might remember, earlier we touched on the query language SQL. In this video, you'll see SQL in action and finally learn what you can do with it by taking a look at some examples of specific queries. I guess you can call this the SQL sequel. We'll try to make this one at least as good as the first. Remember, SQL can do lots of the same things with data that spreadsheets can. You can use it to store, organize, and analyze your data, among other things. But like any good SQL, it is on a larger scale, bigger, more action-packed. Think of it as supersized spreadsheets. For example, you might want to consider a spreadsheet when you have a smaller data set, like 100 rows. But if your data seems to go on forever and your spreadsheet is struggling to keep up, SQL would be the way to go. When you use SQL, you'll need a place where the SQL language is understood. If you've ever gone somewhere and not known the language, it can be challenging to communicate. You might think you're asking for one thing and get something completely different. Well, SQL knows that feeling. SQL needs a database that will understand its language. So let's talk. There are a number of databases out there that use SQL. You may use several of them during your time as a data analyst. But here's the thing. No matter which database you use, SQL basically works the same in each. For example, in SQL, queries are universal. We've talked about queries before, but it never hurts to have a refresher. A query is the way we use SQL to communicate with the database. Here's the structure of a basic query. You can see that with this query, we can select specific data from a table. By adding where, we can filter the data based on certain conditions. All right, let's get started. We'll open our database and see how SQL can communicate with it to do some simple data tasks. First, let's select our data. We'll use an asterisk to select all of the data from the table. And with that simple query, the database calls up the table we need. Magic. Let's add where to the query to show how that changes what data we get. You can see that the data now only shows movies that are in the action genre. And that's it. A basic query in SQL. Pretty cool, huh? There are plenty of other commands that you'll use in queries as you continue. For now though, we can celebrate learning about 3 big ones: select, from, and where. As you continue the program, you'll have the opportunity to use SQL yourself. So I hope that this video was a useful sneak peek at what's coming later. Like with any new language, learning it takes time. And now, it's time to move on.
I'm Angie. I'm a program manager of engineering at Google. I'm currently working on the data analytics certificate, and previously I was a researcher in people analytics. I was also what I call an analytical mercenary, working for a lot of different companies to help them make sense of their data. Every time I learn a new skill, I feel like I'm learning how to speak all over again. I remember the first time I learned SQL, I was so frustrated because everyone around me it felt like they were fluent. They knew exactly what they were doing. And I remember struggling with the most basic things, just like getting the data out of the table, right? Or I remember somebody asked me just to find like an average of something, and I kept on getting an error. And it really does feel like you're learning a new language and you're at toddler level and everyone around you is like maybe fluent. So my parents immigrated to this country when they were in their 30s. So after, they had learned another language and they had to start over and learn, English. And I remember as a child watching them struggle every day to pick up a new language, to do really basic things, like ask for help at the grocery store. I remember calling the cable company when I was 6, asking them questions about the bill because my parents couldn't. And I remember how hard they worked to learn this new language and to become fluent, and every time I'm learning a new data language like SQL or R, I think about how hard that must have been. And I think if they can do that, I can learn SQL. If they can ask for help for the most basic of things, I can ask the data analyst next to me, how to write a SQL statement, how to get data out of a table. And that's really helped me, is just having that mindset and knowing that I can ask for help.
Wow, your data analysis toolbox is getting full. Learning about both spreadsheets and SQL will get you far in the world of data analysis. There's more to learn, of course, and lots more tools you'll be able to use. But your future is looking bright. And it's about to look even brighter, because we're here to talk more about data visualization. I'll tell you a little more about the role of data visualization tools in data analytics and give you a chance to see those tools in action later in this video. You might remember that data visualization is the graphical representation of information. For tons of data analysts, it's the most exciting part of their job because they get to see their hard work pay off with something interesting. Not to mention that data visualization is beautiful and useful. I was floored when I got to Google and started to get a quarterly data report in my email. It had a big slide deck where people contributed their visualizations. It was definitely a source of light as I started to build my own visualizations. If you're not impressed by my story, let me tell you about Florence Nightingale. Does that name ring a bell? She's responsible for much of the philosophy of modern nursing. And believe it or not, she was also a data analyst. During the Crimean War in the 1850s, thousands of soldiers were dying every day. Nightingale wanted to find a way to reduce the number of deaths. After examining the data, she found that the majority of soldiers were dying from preventable conditions. To convince hospital administrators that they needed to focus on these conditions, she created a chart showing the number of deaths over several months. The much larger blue sections in the visualization represent the preventable deaths. Her work directly led to major changes in patient care. And she did all of this over 150 years ago without a computer. One of the main reasons Nightingale created this visualization was to make the data easier to digest for her audience. She felt she'd be more successful convincing the stakeholders using visuals instead of just words and numbers. She was right. Tables filled with data, while necessary for analysis, just aren't able to show trends and patterns as quickly and clearly as visualizations can. Imagine you receive an assignment that needs to be completed the same day. You gather the data you need in a table. Could you explain your findings using the table? Yes, you probably could. But a better idea would be to use a visualization like this bar graph. Something like this makes it much easier for you to explain quickly. And you've got the benefit of a cool graphic to back up your analysis. As a data analyst, you'll want to create visualizations that make the data easy to understand and interesting to look at. So show it off. Stakeholders may not have much time to devote to the data. Your job will be to make their time worthwhile. Let's go back to that data table we created earlier in the course. If you created your own for practice, you can open it up now or try this out later. Here's the data we added before. Let's create a visualization of the data by inserting a chart, a bar graph. Boom. You can see that the spreadsheet visualized the data from our table in a way that made the most sense. It created a bar graph or column chart to compare the ages of each person by name. But you might have figured that out already. That's the beauty of visualization. It shows data analysis quickly and clearly. We can use Chart Editor to adjust the chart. Different spreadsheet programs might have different ways to do this, but they all have visualization functions and ways to edit those visualizations. All right, for now, let's just look at the suggested charts. We can make the bars go horizontally using a bar chart. That looks great. So let's close the chart editor. There are lots of options to look at, but we'll keep it basic for now. Feel free to try other visualizations if you practice later. Now we can adjust our chart to make our whole spreadsheet look clean and professional. Excellent. I hope you learned to love data visualization as much as I do. Maybe you'll become a data visualization pioneer just like Florence Nightingale. As a budding data analyst, you've started to fill your utility belt with valuable tools that you'll use throughout the rest of the program. Having spreadsheets, SQL, and data visualization know-how will help make you an ace data detective. You'll be able to use these tools throughout the data analytics process as you move forward. Coming up next, you'll complete a few activities to wrap up this part of the program. You'll also complete an assessment to check your understanding of all that you learn. This is a great opportunity to think about some of the areas that you'll continue to explore in this course and in your career. As always, feel free to review the videos and readings to help remind you of certain topics and ideas, even if you already feel prepared. You're just a few steps away from the next course. That's great progress. Keep it up.
My name is Lilah Jones, and I am a part of our cloud team. I get a chance to lead a team of amazing individuals that are focused on helping customers get to the cloud. Data visualizations. That's a long word, and that can also make your eyes glaze over. But I wonder if when you were little and you were with your parents, maybe they had a bedtime routine, or maybe you have children, you're doing a bedtime routine with them, you very rarely are going to come to those children with a bunch of facts and figures before they go to bed. But I bet you probably are telling them a story. You're showing them pictures. I know I always loved comic books. Pictures tell a story. Data visualizations are pictures. They are a wonderful way to take very basic ideas around data and data points and make them come alive. You can do all different types of combinations of visualizations, but the ones that are interactive, wow, those are huge. Can you imagine being an executive in an organization and trying to figure out, wow, should we open up another site in Bangkok? Does that make sense? And us being able to walk in and saying, here's why it makes sense, and having great data visualizations to support all of our points of view makes it a no-brainer. Interestingly enough, I do recall the first time I came across a super amazing visualization. It was in my personal life. I switched my budgeting software from one provider to another. And the provider that I switched to was really focused on every dollar has a job and making sure you're budgeting every single dollar. They gave visualizations that changed depending on what input you would add to it. And it really just changed my entire perspective, the entire thing. So having the data is like having the answer sheet for a test. It really just lets you know that you're going to make good decisions because it's backed up by data.
Hi, in this video, we're going to be taking a look at how you can access Qwiklabs from within your Coursera user interface. Let's take a look. Here we are, and you're working your way through a course, and you see inside of your left side bar a graded external tool. Now, first of all, you should get excited. That's where you're actually going to apply a lot of these concepts that you learned hands-on inside of our Qwiklabs. But how do you get from Coursera to Qwiklabs? It's pretty easy. It'll take us just about a minute. So what you're going to do, you land on this page. We have some tips and tricks here for you, and I'll walk you through one key important one. The number one thing that I normally get wrong when I'm recording these videos or taking Coursera courses with Qwiklabs myself is that you want to make sure that you're in a private browsing or an incognito mode window inside of your browser. Why would you want to do that? Well, if you're logged into Coursera with incognito, and keep in mind you might have to go through a CAPTCHA by selecting some images to make sure that you're not a robot before you go through, it allows you not to accidentally make the mistake of logging into Qwiklabs or Coursera with any email that you don't intend to. So once you're here and making sure that you're in an incognito window, and if you're using Chrome in the upper right hand corner, you can just verify there's this little incognito icon here, then you're good to go. All you got to do is scroll down to the bottom, click the I understand box, add your initials, and the most important thing that you're going to see is Open Tool. In the lower right hand corner, this button will become nice dark blue once you've checked that button. You open the tool and you'll see a new browser window come up. Now, unless you want to hear my voice again, you can just click skip this video because that's just an introduction. There's also an X in the upper right hand corner for you, which will then take you into the Qwiklab itself. So to do your work, you should now have two different tabs in your browser. One has all the video lectures inside of Coursera, and the other has the actual hands-on Qwiklab. And that's going to be the subject of our next video, where you're going to learn all about how you can get credit for your work done inside of the Qwiklabs. We'll see you there. Welcome to Qwiklabs. Now it's time to get hands-on practice on a lot of the amazing data analyst concepts that you've learned so far. Here's where you get to prove that you've learned some great technologies, and then you'll get credit for it back inside of Coursera. But before you jump right in, let me just give you a quick walkthrough of what a Qwiklab is, and then we'll get started. First and foremost, in the upper left-hand corner, you notice a gigantic tempting button called Start Lab in green. I want to go ahead and start that. Click this box that says I'm not a robot. Select a few of the different items here for captures. You can see this is the hardest part of the lab, is trying to actually get through the anti-robot technology that they have here. Now, a couple things happen in the background. As author of these labs, this is some of our best work that we're getting you hands-on practice for. And what we're going to do next is just make sure that that timer starts counting down, because then that's going to give you the account logins that you need to practice the work inside of the lab. Now, here's what you're going to do. There's going to be a gigantic big button that says Open Google Cloud Console. I want you to go ahead and click on that. And now you have 3 browser tab windows open, or 100 if you're like me. And in the second browser, this is your Qwiklabs login. All the way under username, what I want you to do is copy that username. And here's the #1 mistake that I've seen students make. When you're back into Google, everyone sees this Google sign-in screen here, and they immediately start typing in their personal Gmail address. You don't want to be charged for any of the resources that you're going to be using. That's why we're providing you with this Qwiklabs account yourself. All I'm going to do is paste in the email that's been given to me by the Qwiklab for use for an hour, and then click Next. And then I'm going to go ahead and grab the password, paste that in here, and then you're going to see a bunch of terms and conditions because this is a brand new account. Scroll through the terms and conditions, read them at your leisure, click Accept. And as you work through the terms of service here, eventually you'll land on the homepage for Google Cloud. Scroll down, read the terms of service, accept terms of service. All the steps that I'm walking you through right now are also available inside of the lab written instructions as well. So once you've gotten that out of the way, let's take a look at what this particular Qwiklab is going to teach you. At a high level, I'm not going to do the lab for you, but don't worry, it's step by step. You'll have a blast doing it. And you have way more than enough time you need in this timer before your lab timer runs out. Generally, as lab authors, we try to double the budget of allowed time, so don't worry about lab timeouts. So inside the lab, every lab will start with an overview, and then what specifically it is that you're going to do. Inside of this lab, since you're a data analyst, you're going to be creating spreadsheets and adding files and sharing files with some of your other data analysts. If you forget what section you're in, another pro tip that I like to do is on the right-hand side, you can actually click between each of the different header sections right here as I'm doing now, and you can jump to a particular section inside of the workbook. So say you and your friends are working on this together, you can say, hey, I'm having trouble on the share and collaborate section. You can just click on that and it'll jump right to that section. Well, that's pretty much it. A few more housekeeping items and then you're off to the races. As you work your way through the lab, you want to make sure that you're completing the objectives and making sure that you're staying on track. There is intelligence built into the Qwiklabs to prevent any kind of behavior that's not part of the lab. So make sure you're following the lab as is. And when you're done with the lab, say I was completed here, all you have to do is click on End Lab, click on OK, and that's going to bring you to a pop-up screen that asks you to rate the lab, add in any comments for the lab authors like me, submit it, and then automatically your score for the work that you've done in the lab is fed back to Coursera, which is pretty cool. And that's it. That was a quick tour of Qwiklabs, about 5 minutes, but honestly, you'll have a blast going through these. Good luck. Next, we're going to cover a really important topic, which is how to get help with Qwiklabs should you need it. And to do that, we're going to jump back into our Qwiklabs user interface. Here I am back inside of the Qwiklab. Inside of the Qwiklabs user interface, if you're working through a lab and just something's not acting right or the lab instructions don't seem to be telling you exactly what you need to do, we try our hardest to make sure that the labs are step by step, but at any point in the lower right hand corner, you can click on the chat bubble. Once we've done that, add in your name, add in your email, and you can optionally define the department for Qwiklabs. I'm going to say Qwiklabs General Support, and you can start a chat. So let me go ahead and add my name, add my email, and start chat. And then this window will pop up. Now this gets you connected with the Qwiklabs live support representative. They're amazing, they're friendly, they've been doing this for years, and likely your problem has already been encountered by somebody before. So don't hesitate, drop them a line, and if they're out of office, it'll automatically create a support ticket where they'll follow up with you from that email address that you provided. That's it. Have fun working through your labs and earning that credit.
Hey, great to have you back. Now it's time to get down to business. we're going to start talking about practical ways businesses are using data and the opportunities that it can create for you. So far, you've learned a lot of practical data analysis skills. With these next couple of videos, we're going to switch gears a little and talk about why you're learning these skills. Hopefully this will give you more perspective into what kinds of opportunities are out there for you. Coming up, we're going to talk more about the kinds of roles data analysts play in different industries, the tasks that these roles require, and the importance of fairness and avoiding bias in analyzing data for business tasks. We'll also talk about opportunities you can tap into and how this program factors into your future success in the data analyst role. So with all that in mind, let's get started. Previously, we learned about what a data analyst does and why that work is so valuable. Now, let's look at where data analysts actually do their work. You'll learn much more about the industries you could work in as a data analyst and how companies in these fields are already using data analytics to do some really cool things. There are so many businesses out there that have a big need for the skills you're learning right now. Across industries like technology, marketing, finance, healthcare, and so many more, real companies are already using data analytics to stay ahead of the curve. And the more they use data in their business, the more they understand just how important data analysts like you are to their success. Let's look at a real-life example of a brand you'll probably recognize, Coca-Cola. Data is changing the way Coca-Cola approaches its marketing strategies. Coca-Cola uses data gathered from consumer feedback to create advertising that speaks directly to different audiences with different interests. How does this work? You know those high-tech Coca-Cola vending machines you see at movie theaters sometimes? It's always fun getting to make your own flavors. Well, those machines have built-in artificial intelligence and data analysis tools. This helps Coca-Cola see all the different kinds of flavor combinations people are coming up with, which they can then use as inspiration for new products. How cool is that? Ever wonder how Google gives you the right answer to any question in just seconds? That's powered by data too. We use all kinds of data to determine a website's reliability and accuracy to make sure you get the most useful results for any search you make. But it isn't just big companies like Coca-Cola and Google that use data. Small businesses everywhere are also starting to take advantage of data-driven insights to improve their operations and make better decisions. Small businesses can use data to do all kinds of things. They might use data analytics to better understand their customers' buying habits, create more effective social media messaging, or, in the case of one city zoo and aquarium, predict the number of daily visitors based on local climate data. City Zoo and Aquarium realized that on rainy days, they were seeing huge drop-offs in attendance, but they had no way to accurately predict when those rainy days would hit. This made staffing a real challenge. Some days they found themselves overstaffed. Other days, they were unprepared for the rush of visitors. To deal with this, data analysts took years of weather records from the zoo and used that data to accurately predict future weather patterns. This made it easy for the zoo to know how much staff they needed when. Because the zoo could predict and manage their staffing needs more accurately, they were able to provide a better experience for visitors and dedicate more resources to creating a better experience for the animals too. We see a similar thing in the healthcare industry. There, data analysts look at clinic attendance data to help hospitals and doctors' offices predict when rush hours will hit so they can be ready for it. Your local city hospital is a great example. Let's say they've been getting complaints about long wait times, sometimes an hour or more, which made it hard for some patients to get the care they needed. So data analysts use data about the hospital's daily foot traffic to help them make more informed decisions about how many doctors they need on staff at any given time. This helped reduce wait times, improve their patients' experience, and make better use of the healthcare workers' time too. Like I said, there are many ways that companies in different industries put data to use, but they can only do that if they have data analysts they can rely on. So you might be wondering how you fit into the equation. Well, you've got plenty of options, but you don't have to decide what industry you want to work in right away. There will be plenty of time to think about that as you make your way through this program. By the time you finish this program, You'll have the core skills that will make you valuable in any industry that makes data-driven decisions, which, as it turns out, is most industries, even zoos. Coming up, we'll check out the business task where data can be helpful, and we'll explore even more how data analysts are empowering businesses through data. I'll see you then.
Hi, I'm Joey, and I work as an analytics program manager within RUSE. Now, RUSE stands for Real Estate and Workplace Services, and my job is to bring data and analytics into the decision-making here, especially with regards to creating a safe and fun work environment. My journey into analytics was a bit different in that I had no plan or really didn't see myself being where I am now. Now, luckily, I started in a rotational program called the HRA program within people operations, which afforded me the ability to play 3 different roles, essentially. I was in a generalist capacity, in a specialist role, and as an analyst. And I really found a love and a passion in the analytical work. I started on the business intelligence team, whose job was to provide SQL-based reporting back to the business. I realized that analytics is the right career path for me when I found myself enjoying coming to work and getting my work done. And I think I can connect that to 2 passions of mine. The first is problem solving. I love taking a complex problem, a mystery, a riddle, and being able to find the answers and come up with the solution. And then the second thing is being able to work with people and help people. In analytics, I feel like the key to success is being able to blend the personal side with the technical side. At the beginning of my career, I focused a little more on the technical pieces, and I wanted to make sure I had the right technical knowledge to be able to answer questions. But what I found is, over time, I needed to grow that other side just as much. And I think that my career has allowed me those opportunities to kind of work each of those muscles, the human interaction part and the technical part, to make sure that they're both growing at the end of the day.
For any analyst, for any person that's honestly at the early stages of their career, understanding data, respecting data, knowing how to work with data is incredibly important because, my vision is that every role in some form or fashion will involve data, and its use in learning how to extract insights from it will be at the core of any critical role across any company or organization. Generally, in those first 2 years, you're developing the core skill sets that make you a fantastic generalist. And then in the next 2 to 5 years, you're learning about something very specific as it relates to your job. So whether it's the area that you're supporting or maybe a very technical component, like let's say you want to become a SQL expert so that you can manipulate large data sets for financial analysis purposes. Similarly, even if you come into finance as a data analyst, you can pop out of finance and go into what a lot of people like to call the business, which is typically your operations functions, and become a business analyst or a data analyst. There's so many different paths that you can take from the starting point that you really can't predict you're in. I'm just deeply passionate about working with and supporting young people and really giving them a jump start to their career. This stems from, honestly, my own personal experience, where in the first 2 years of my career, I had essentially 0 support from my manager and my direct management chains. Having gone through that experience in my first 2 years, I realized and I experienced how that can slow you down. And especially when you're somebody that has a lot of potential and a lot of ability, you want to be in an environment that fosters that ability and really wants to see you grow. I think it's incredibly important to have programs like these that take away all the barriers, that remove any of the constructs that prevent people from being able to find out what they need to be in an industry like this, to be successful in a role like a data analyst, so that they themselves can dream about where they can go in their career. My name is Tony. I'm a finance program manager at Google. As a data analyst, you'll be tackling business tasks that help companies use data. Coming up, we'll talk more about what a business task actually is and some examples of what they might look like in real data analyst jobs. Let's take a second to think back on the real examples of businesses using data analytics in their operation we've seen before. You might have noticed a common theme across every example. They all have issues to explore, questions to answer, or problems to solve. It's easy for these things to get mixed up, so here's a way to keep them straight when we talk about them in data analytics. An issue is a topic or subject to investigate. A question is designed to discover information, and a problem is an obstacle or complication that needs to be worked out. Coca-Cola had a question about new products. Data analysis gave them insights into new flavors customers already like. The city zoo and aquarium had a problem with staffing. Data helped them figure out the best staffing strategy. These questions and problems become the foundation for all kinds of business tasks that you'll help solve as a data analyst. A business task is the question or problem data analysis answers for a business. This is where you'll focus a lot of your efforts in the work you'll do for future employers. Let's stick with our zoo example and see if we can imagine what a business task for a zoo might look like. We know the problem. Unpredictable weather was making it hard for the zoo to anticipate staffing needs. So maybe the business task could be something like analyze weather data from the last decade to identify predictable patterns. The data analyst could then plan out the best way to gather, analyze, and present the data needed to solve this task and meet the zoo's goals. Then, using data, the zoo would be able to make informed decisions about their daily staffing. So we talked a little about data-driven decision-making in previous videos. But just in case you need a refresher, here it is. Data-driven decision-making is when facts that have been discovered through data analysis are used to guide business strategy. The simplest way to think about decision-making is that it's a choice between consequences, good, bad, or a combination of both. In our zoo example, the zoo had the data they needed to make an informed decision that solved their problem. But what if they had made this decision without data? Let's say they just relied on observation and memory to track the weather and make staffing schedules. Well, we already know that wouldn't have solved their problem long term. Data analytics gave them the information they needed to find the best possible solution to their problem. That's the power of data. Observation and intuition are powerful tools in decision making, but they can only take us so far. When we make decisions based on just observation and gut feelings, we're only seeing part of the picture. Data helps us see the whole thing. With data, we have a complete picture of the problem and its causes, which lets us find new and surprising solutions we never would have been able to see before. Data analytics helps businesses make better decisions, and it all starts with a business task and the question it's trying to answer. With the skills you'll learn throughout this program, you'll be able to ask the right questions, plan out the best way to gather and analyze data, and then present it visually to arm your team so they can make an informed, data-driven decision. And that makes you critical to the success of any business you work for. Data is a powerful tool, and with great power comes, well, you know the rest. And you're doing a super job taking in all of this information. Up next, we'll talk about your responsibility as a data analyst to make sure you're gathering, analyzing, and presenting data in a way that's fair to the people being represented by that data.
Hi, my name is Rachel, and I'm the Business Systems and Analytics Lead at Verily. There are a lot of different types of problems that a data analyst can solve. I've been lucky enough over my career to have seen a lot of them and to take in a lot of very different types of data and help turn that into meaningful answers. I think one of the most important things to remember about data analytics is that data is data. I'm a finance data analyst, and so my role at Verily is to take all of our financial information, all of the information of the money we're spending and the money we're making, and turn that into reports and insights so that our business leads can understand what we're doing. One of the most important things I've done at Verily recently was help create what's called a profit and loss statement for each of our business units. And that means that in real time, our teams can see what their budget is and how they're spending against that budget. And what that does is that helps our teams keep to that budget by either increasing their revenue streams so that they have more money to play with, or pulling back their spending so that they can keep themselves within that budget. And all of that really helps keep us on track as a company and making sure that we're hitting our goals. I've found that data acts like a living and breathing thing. When you have a ton of data points, it can be overwhelming when you first sit down to make sense of it. You have tons of columns, tons of records, tons of different types of data, and finding a way to make sense of that is really hard. And that's where the expertise of a data analyst comes in. It has been some of the most frustrating moments of my career, but also some of the most rewarding work I've ever done when it finally comes together. The best advice I have for any data analyst starting out is keep at it. If the angle you're taking doesn't work, try to find another one. Try to come at it in a different way. Try to ask a different question. Eventually, the data will yield, and you'll get the insights you're looking for.
So far, we've covered the different roles data analysts play in business environments and the kinds of tasks that come with those roles. But data analysts have another important responsibility: making sure their analyses are fair. Now, I know what you're probably thinking. Data is based on collected facts. How can it be unfair? Well, that's a good question. So let's learn what fairness means when we talk about data analysis and why it's important for you as an analyst to keep in mind. Fairness means ensuring that your analysis doesn't create or reinforce bias. In other words, as a data analyst, you want to help create systems that are fair and inclusive to everyone. Sounds simple enough? Well, here's the tough part about fairness in data analytics. There isn't one standard definition of it, but hopefully the way we've just described it can give you one way to think about fairness for right now. But it's about to get a bit trickier. Sometimes conclusions based on data can be true and unfair. What can you do then? Well, let's find out with an example. Let's say we have a company that's notorious for being kind of a boys' club. It's very male-dominated, and there aren't many women employees. This company wants to see which employees are doing well, so they start gathering data on employee performance and their own company culture. The data shows that women just aren't succeeding as often as men in their company. Their conclusion? That they should hire fewer women. After all, women are doing poorly here, right? But that's not a fair conclusion, for a couple of reasons. First, it doesn't even consider all of the available data on company culture, so it paints an incomplete picture. Second, it doesn't think about the other surrounding factors that impact the data, or in other words, the conclusion doesn't consider the difficulties women have trying to navigate a toxic work environment. If the company only looks at this conclusion, they won't acknowledge and address how harmful their culture is, and they won't understand why women are set up to fail within it. That's why it's important to keep fairness in mind when analyzing data. The conclusion that women aren't succeeding in this company is true, but it ignores the other systemic factors that are contributing to this problem. But don't worry, there's a way to make a fair conclusion here. An ethical data analyst could look at the data gathered and conclude that the company culture is preventing women from succeeding, and the company needs to address these problems to boost performance. See how this conclusion paints a much more complete and fair picture? It recognizes the fact that women aren't doing as well in this company and factors in why that could be, instead of discriminating against women applicants in the future. As a data analyst, it's your responsibility to make sure your analysis is fair and factors in the complicated social context that could create bias in your conclusions. It's important to think about fairness from the moment you start collecting data for a business task to the time you present your conclusions to your stakeholders. We'll learn more about bias in the data analysis process later on in another course. For now, let's check out an example of a data analysis that does a good job of considering fairness in its conclusion. A team of Harvard data scientists were developing a mobile platform to track patients at risk of cardiovascular disease in an area of the United States called the Stroke Belt. It's important to call out that there were a variety of reasons people living in this area might be more at risk. With that in mind, these data scientists recognized that fairness needed to be a priority for this project so they built fairness into their models. The team took several fairness measures to make sure they were being as fair as possible when examining sensitive and potentially biased data. First, they teamed analysts with social scientists who could provide insights on human bias and the social context that created them. They also collected self-reported data in a separate system to avoid the potential for racial bias, which might skew the results of their study and unfairly represent patients. And to make sure their sample population was representative, they oversampled non-dominant groups to ensure their model was including them. It's clear that the team made fairness a top priority every step of the way. This helped them collect data and create conclusions that didn't negatively impact the communities they were studying. Hopefully these examples have given you a better idea of what fairness means in data analysis. But we're going to keep building on your understanding of fairness throughout this program, and you'll get to practice with some activities.
Hi, I'm Alex. I'm a research scientist at Google. My team is called the Ethical AI team, and we're a group of folks that really are concerned not only about how AI and the technology operates, but how it interacts with society and how it might help or harm marginalized communities. So when we talk about data ethics, we think about, what is the good and right way of using data? What are going to be ways that are going to be uses of data that are going to be beneficial to people? When it comes to data ethics, it's not just about minimizing harm, but it's actually this concept of beneficence. How do we actually improve the lives of people by using data? When we think about data ethics, we're thinking about who's collecting the data, why are they collecting it, how are they collecting it, and for what purpose? Because of the way that organizations have imperatives to make money or to report to somebody or provide some kind of analysis, we also have to keep strongly in mind how this is actually going to benefit people at the end of the day. Are the people represented in this data going to be benefited by this? And I think that's the thing you never want to lose sight of as a data scientist or a data analyst. I think aspiring data analysts need to keep in mind that a lot of the data that you're going to encounter is data that comes from people. So at the end of the day, data are people. And you want to have a responsibility to those people that are represented in those data. Second is thinking about how to keep aspects of their data protected and private. We don't want to go through our practice thinking about data instances as something we could just throw on the web. No, there needs to be considerations about how to keep that information and likenesses like their images or their voices or their text. How do we keep that private? We also need to think about how we can have mechanisms of giving users and giving consumers more control over their data. It's not going to be sufficient just to say we collect all this data and trust us with all these data, but we need to ensure that there's actionable ways in which people can consent to giving those data and ways that they can ask for it to be revoked or removed. So data is growing, and at the same time, we need to empower people to have control over their own data. The future is that data is always growing. We haven't seen any kind of evidence that data is actually shrinking. And with the knowledge that data is growing, these issues become more and more peaked and more important to think about.
By now, we know that there are all kinds of jobs in different industries available for data analysts. But now, it's time to think about something just as important. How can you tell if a job is a good fit for you and your career goals? Tough one, right? Don't worry, that's exactly what we'll cover in this video. There's a lot of important factors to think about when searching for your dream job. Let's talk about some of the most common factors first. Industry, tools, location, travel, and culture. Data is already being used by countless industries in all kinds of different ways. Tech, marketing, finance, healthcare, the list goes on. But one thing that's important to keep in mind, every industry has specific data needs that have to be addressed differently by their data analysts. The same revenue data can be used in 3 different ways by data analysts in 3 different industries: financial services, telecom, and tech. For example, a finance analyst at a bank pulls public revenue data of telecom company X to create a forecast that predicts where revenues will be in the future to recommend a stock price. The business analyst at telecom company X uses that same data to advise the sales team. Then a data analyst at the company who created a customer management tool for telecom company X will use that revenue data to determine how efficiently their software is performing. Finance, telecom, and tech all use data differently, so they need analysts who have different skills. It all comes down to what the needs of the industry are. Those needs will determine what kind of task you'll be given, the questions you'll be answering, and even how you'll approach job searching. If you're just starting out, a great way to guide your search is to think first about what you're interested in. Does helping people get healthier sound meaningful to you? Maybe you want to focus on using data to improve hospital admissions. What about helping people save for a happy retirement? You might want a job that uses data to determine risk factors in financial investments. Or maybe you're interested in helping journalism grow in your city. A job using data to help find your local news website find more subscribers could be the perfect role for you. The key is to think about your interest early in your job search. That'll lead you in the right direction, and it'll help you in interviews too. Potential employers will want to know why you're interested in their company and how you can address their needs. So if you can speak about your motivation to work in data analytics during interviews, you'll make yourself stand out in a great way. You'll have options when it comes to where you work and who you work for. But remember, you want to enjoy what you do. So it's a good idea to think about how you want to use your skills, then search for jobs that allow you to do that. Next on the list of things to think about, location and travel. When you start your job search, you need to make some decisions about where you want to live. So it helps to ask yourself some questions. Does your preferred industry have opportunities in your area? Are you trying to stay local, or would you be happy relocating? How long are you willing to commute to work every day? Will you drive to work, walk, take public transport? Is that possible year-round? How do you feel about working remotely? Does working from home excite you or bore you? And of course, you'll want to consider cost of living and whether or not you want the convenience of city living or a quiet suburban home. And it's not just about where you'll be based. Some jobs may ask you to travel, which could be an exciting chance to see the world or a deal breaker. It's all about what you want out of this job. So start asking yourself some of these questions. Figuring out the answers can help you narrow down your search even further, so you're only looking at jobs you'd actually accept. Once you've answered enough questions, you'll be able to identify some specific companies that fit your needs. At this point, it's a good time to think about your values and what kind of company culture is a good fit for you. Ready? Here come some more questions. Do you work best in a team or by yourself? Do you like to have a set routine, or do you enjoy taking a new project and trying new things? Do your values match the company's values? You'll want to pay attention to these things during your job search and interview process so you can be sure you fully invested in the company you work for. That's the best way to start building an exciting and fulfilling career. This program will help you learn the core skills for data analytics in any setting. It's up to you where you want to take them. Whether that means starting in a completely new industry or moving into an analyst position in an industry you already have experience in. And hopefully what we've covered here has helped you get on track for your future job search. After this, you'll have a few activities to do, and then you'll be able to move on to the next part of this course. We learned a lot so far, like what kinds of opportunities are out there for data analysts in different industries, how data analysts help businesses make better decisions, the importance of fairness in data analytics, and the potential questions you can start asking yourself before your future job search. And you can always look back at these lessons if you want to review. In an upcoming course, we'll look at the skills all successful data analysts have and you'll learn how you can start practicing them too. But before that, you'll have an assessment. Good luck, and I'll see you later.
My name is Samah Moid, and I'm a recruiter here at Google for the large customer sales team. Basically, I hire talent for the sales team here. Even within the sales recruiting space, I recruit specifically for the analytical lead roles here at Google. I want the candidate to be as comfortable as possible. As a recruiter, I'm also their advocate. If they're a good fit for the team, I'd like to present them in the best light. As a recruiter, some advice I would give for a data analyst that's just starting to look for a job: think about a time where you've used data to solve a problem, whether it's in your professional or personal projects. Another tip I would say for a data analyst that's just looking for a new job is to increase your professional network. There are many ways to increase your professional network. One of them is to increase your online footprint, reach out to other analysts on LinkedIn, join local meetups with other data scientists. Sometimes when we're looking for a unique skill set, recruiters are going on websites like LinkedIn and GitHub and trying to find that talent themselves. It's really important to have your LinkedIn updated along with websites like GitHub, where you can showcase a lot of the data analyst projects you've done. Another tip I would say for an in-person interview is to prepare questions for the interviewer. Make sure they're not broad questions. They should be questions that will help you understand the team and the job better. If you're given a case study in an interview, you should expect to be given a business problem along with a sample data set. Then you'd be asked to take that sample data set, analyze it, and come up with a solution. One of the things you can do to help prepare yourself for this is to ensure you are analyzing the data and coming up with a solution that relates back to that data. Sometimes there is no right answer, and a lot of times interviewers are looking to see your thought process and the way you get to your solution. I highly encourage that if you find a role that you're interested in, not only apply to it, but go the next step. Look for the recruiter, look for the hiring manager online, see if you can reach out to them and set up a coffee chat, or send them your resume directly. Online applications could be a really big black hole where you never hear back from the recruiter or the team. When you reach out directly to a hiring manager or recruiter, it really shows your eagerness for the role and your interest for the role. Even if sometimes you don't get a response from reaching out, you never know. You try multiple different times, and that one time you get a response back from a recruiter or hiring manager could be the time you get the job that you really wanted.
We're at the end of this course, which means it's time to show off what you've learned. We've covered the different kinds of industries using data to drive decisions and how you can help them, how to promote fairness in your data work, and opportunities that are out there in the world of data analytics. I know you've got this, and once you finish the course challenge, I'll be right here to introduce you to the next course. Congratulations on finishing this first course. You've already learned a lot, and you're ready to take what you've learned and move forward. And if you ever need a refresher, just remember that these videos will still be here whenever you need them. You might remember your next instructor from our introduction at the beginning of the intro course. Get ready to meet my fellow Googler and your instructor for the next course, Jimena. She's ready to help you get started on your next step towards finishing this program and becoming a data analyst. This next course will build directly on some of the topics that you've learned so far and give you insight into the things we've already talked about. Like any good detective, you'll learn how to ask the right questions and use data to find answers. Employees in every industry need to become comfortable asking questions, but this can especially be true for data analysts. A lot of data analysts try to make their work perfect the first time, even though they might not have all the information. Instead of asking questions, they make assumptions. That can lead to mistakes. It's so much better to be humble and inquisitive, and to ask questions. I'll show you what I mean. One of the analysts I supervised came into Google with no coding experience. He was nervous about leaving a great first impression, so he tried to study up on multiple languages by himself before he started. When the work actually began, he didn't ask us, his team, questions, or ask us for help when he ran into roadblocks. There are a lot of great places to find answers, especially online, and his initiative helped him find some of those places. But at the end of the day, he forgot to tap into his best resource, us, his team. Because he was nervous about how he would be perceived if he asked us for help, he almost missed out on some great insights from his team members. As roadblocks persisted, he realized he needed to make a change. He stopped trying to guess expectations, processes, and more all on his own and started asking us more questions. As soon as he embraced this new approach, he skyrocketed on our team. His learning went straight up the curve like a hockey stick. His impact on the organization, the number of people who reach out to him, and his career path going forward all did the same. The bottom line is, you don't need to know it all. The saying is true. There are no bad questions. Being open to learning is one of the most important qualities for a data analyst. Speaking of learning, in the next course, we'll go into more depth learning about basic spreadsheet skills and when you'll need to use them. You'll discover how to apply structured thinking to data work, and you'll focus on how to best meet stakeholder needs and expectations by gathering all the clues. Great work, and good luck on the next course.